Today's demonstration video is going to be about Vibe-Kanban. Vibe-Kanban is an AI orchestration tool that you can use to orchestrate software development lifecycle tasks. Sometimes this is referred to as semi-autonomous software development, autonomous software development, or software factories. The TLDR on this is that using an orchestration tool such as Vibe-Kanban and integrating it with your source control repository, you can have it use AI tools to work on tasks autonomously. Using the tool, you can instruct the AI agents to develop software to test and verify, as well as to check in, commit, and create pull requests in your GitHub repository. These work items can be completed using a serial one-at-a-time process or run in parallel. This is all going to make a lot more sense after watching the video. For this demonstration, we will be using Vibe-Kanban, a GitHub repository. We'll be using Qwen AI for our AI API, Docker for our Sandboxed development environment. There are some important considerations to discuss when using AI orchestration tools such as Vibe-Kanban. One of the considerations is that in order to efficiently use AI orchestration tool, you need to run your AI API using the dangerously skip permissions flag, as well as run it in YOLO mode. Running in this mode, because of the constant iterations while working through the code, your API usage can start to add up quickly and can become expensive. In this demonstration, we will be using Qwen AI. Qwen AI allows you to set up a free account with generous daily usage limits. Enough for this project. The other concern is that with using dangerously skip permissions flag, the AI agents will have a high level of trust on your local system. This can potentially open you up to things such as prompt injection attacks. Such attacks piggyback off permissions that you've provided to the AI agent. Fortunately, there's a good way to mitigate the risks, and that is to use a sandboxed isolated environment. In this demonstration, we will be using a dev container, which is a Docker image and container that only has permissions to a specified volume amount. This will greatly reduce any chance that the AI agent has more permissions and trust on your system than you would desire. Let's discuss a bit the project we will be working on. I decided to use a video that I found interesting on YouTube, posted on the AT&T Archives channel, called the Unix Operating System. About 5 minutes into this video, there's a great explanation of the Kernighan Bell Labs approach. In a nutshell, this pattern uses modular design to compose larger feature sets by piping outputs from one program into another. Brian Kernighan discussed a simple spell checker program for a word processing application that was built using a series of smaller isolated programs to split, sort, organize, and compare words defined in an efficient dictionary test file. We will pay homage by writing our own spell checker composed strictly of built-in Unix commands that exist on most distributions. Structuring a project using this approach helps greatly avoid some of the frustration that can be encountered when you have code sharing dependencies. When you go to commit, there are often merge conflicts that can get complicated to resolve. I seriously recommend that you watch this video. It's full of great information, takes us back to the roots of software development patterns that will stand the test of time, and are especially relevant again because of their usefulness in autonomous or semi-autonomous software development. Given such a great starting point to create the general guidance for the project's development plan, I uploaded the video to Notebooks LM, which uses Google Gemini. I asked it to review the section where the speaker is presenting the particular pattern that he's using to create the word processing program in his demonstration. He explains how the word processing functionality for the demo was created by using smaller programs. Some of the following programs were mentioned in the video that would be used to modularize the spell checker: make words lowercase, sort unique, alphabetize, remove duplicates. I asked Gemini to generate the specification based on this concept and pattern. I also instructed that the dev plan be written in such a way to instruct the AI agent that we want to use built-in standard Unix tools as much as possible, such as sed, grep, awk, etc., to break the project into segmented work items that could be executed in tandem. I then uploaded the development plan generated in Notebooks LM using Gemini to Claude. I asked it to break down tasks and create separate markdown documents for each mini program that will be used in the spell checker. As mentioned, breaking the work items into individualized, semi-isolated tasks will make development for the application much easier when using an AI orchestration agent. Claude created 9 tasks for this project, each one representing a small portion of the bigger solution. Each task is also a self-contained program that can be tested and verified individually. Having tasks broken down into discrete domains will greatly facilitate the ability to create work items and have them work in parallel. The isolation makes it easier to avoid merge conflicts when you have several parallel tasks or work items operating on the exact same code base at the exact same time. Often we see this with traditional object-oriented structured code bases. There's an ironic component to this demonstration regarding software design. Decades ago, we started out with simple patterns like the Kernighan Bell Labs. In the years that followed, we developed more complex patterns and abstractions to facilitate code bases that were to be maintained by humans. With the emergence of AI tools, might it be time to look back at some of these older patterns? Could they in fact be the right patterns? Modularized, smaller programs to achieve larger functionality? Simpler tools such as bash scripting instead of frameworks to do the same job? The first item we're going to be working on is setting up our development environment. As mentioned, this will be a dev container. The reason we are doing this is because we would like an isolated sandbox environment for security reasons. For efficient use of AI orchestration tools, we need to use the dangerously skip permissions flag along with YOLO mode. This could open our system up to risk associated with prompt injections attack. By using a dev container, we isolate our environment so that only the mounted volume can be accessed by the AI agent. Visual Studio Code will allow us to set up dev containers based on images. For our project, we are going to be using the Microsoft Artifact Registry hosted development container image named JavaScript node dev24 bookmark. In order to have this available on your system, you may have to open up a terminal and issue a Docker pull command against this particular image so that you have it loaded on your device. Once you have the image pulled, we're going to use Control-Shift-P and we're going to type dev containers :new to add our dev container. We're then going to select our Node.js and JavaScript container from the dropdown. To verify that we're using the correct image, we're going to look at additional options and see that, in fact, 24 bookworm is the default image that we will be using to create the container. We are going to click on our image and let Visual Studio create our container for us. Visual Studio will create the container and it will open up a new code window that is connected to the container. When our container is up and running, we're going to need to install some tools. The first tool that we will be installing is the GitHub client so that we can interact with our repository. In order to do this, we will head over to the GitHub CLI repository and we will follow the instructions for installing the GitHub CLI tools provided on the README page by following the link. Here we can see the shell script that we need to run in order to install the CLI tools. We will run this from our terminal in Visual Studio Code. After the installation is complete, we're going to have to associate the GitHub CLI with our GitHub account. We are going to do this by issuing the ghauth login command. We will select the defaults as to where we use GitHub and our preferred protocol. We will then authenticate using our browser. It will give us a verification code, and we need to copy this code to our clipboard and follow the provided link. We will then follow the instructions given to validate and verify, which will ask us to verify our email. After this step is completed, our device should be verified and our dev container should be connected using our GitHub credentials. The next tool we are going to have to install in our development container is Qwen Code. We will be using Qwen as our AI API. As mentioned, Qwen Code allows you to set up a free account, and it comes with a generous daily usage limit. If you are following along and you do not yet have a Qwen AI account, go ahead and set one up now, as this will make the authentication process easier when we install Qwen code into our development container, as you will already be logged into your account. We're going to copy and paste the command under Run Qwen Code into our terminal in Visual Studio Code. This is an npx command. After running the npx command in your Visual Studio terminal, follow the authentication instructions so that you will be authenticated against your Qwen code account. You should see a message indicating authentication is successful. Now, before we install Vibe-Kanban, we're going to switch to our home directory. In this example, home/node. And we're going to pull our GitHub repository for the project into our home directory. This way, Vibe-Kanban will be ready to go with a GitHub repository that it recognizes when we start up. At this point, we have an empty repository. We are going to create a main branch. We're going to commit, excluding the need for comments, and push to our repository. Next, we will open up a new terminal and run npx vibe-kanban to install Vibe-Kanban to our dev container. Once running, we will copy the link from the output and open it in a browser. When we open a browser, we will see the Vibe-Kanban onboarding page. This is where we set our initial project settings. Note the warning just below the title. This warning states that the AI coding agents will run with the dangerously skip permissions flag in YOLO mode. This is the reason why we have created a sandboxed container. On this page, you will see options for the settings to be used in the initial project. For the coding agent, Qwen has been selected and Visual Studio Code has been selected for the code editor. After we finish the onboarding process, we're going to add our first workspace. We click on Add Workspace. We then need to click on the Account button to sign into our Vibe-Kanban account. If you don't have a Vibe-Kanban account, you will want to register one. You can do this with a GitHub or Google account. After we have authenticated, we're going to click on Settings and we're going to set our repository. Vibe-Kanban knows about the repository we will be using because we have pulled it into our home directory. If it's not located in your home directory, it's not a problem. You can browse and search for a repository. After we have our repository set up, we can look on the left-hand side and click on IP, which stands for Initial Project. This will open up our workspace. After clicking on that, we are presented a task board. Our task board contains swim lanes for To Do, In Progress, In Review, and Done. To Do is the first state. This is where you enter your prompts for the LLM and any supporting files that you might need. When you create a to-do item in the to-do list, Vibe-Kanban will create a branch in the dev container and pull the latest from main into the branch. You are then presented with the option to create an issue. When you create an issue, this is when the AI agent reads the prompt and starts working on the code base. At this point, the task will move to In Progress. After the AI agent coding has completed, you will be presented with an option to create a pull request. After creating the pull request, you will then have the option to review and approve on GitHub. Once approved, the item will move into the done state. We are ready to start creating our tasks. The first task that we will be creating is called Foundation. There are two tasks that are not meant to be run in parallel. One is Foundation, the other is Integration. Foundation sets up the directory structure and some of the shared test harness classes, so this task will need to be completed before other tasks can be started. As mentioned, the swim lanes that we have are To Do, In Progress, Review, and Done. We start off with the To Do swim lane. We're going to click the paperclip icon. We're going to find our Foundation Markdown document in our file system and attach it to the to-do item. We can see our foundation document has been attached. Note that we see the status above the item, and it is to do as expected. We're going to go ahead and click the Create Issue now. This will actually create the to-do item, but no work will start at this point. We can see our to-do item has been created. Now we're ready to start adding more items. The next item that we're going to add is called spell words. We're going to do this the same way we did the foundation task. I'm going to go ahead and perform the same steps for the rest of the tasks. As you can see, the tasks have been created for each one of our markdown documents. We have the following documents with their associated to-do items: foundation, spell words, spell lower, spell unique, spell mismatch, word processor stats, word processor search, word processor undo, and integration. Aside from the foundation and integration tasks, all these tasks can be run in parallel. We are going to run the foundation task first. If we click on our foundation task in the to-do items list, we will see the details of the respective task on the right-hand side. Because other tasks have dependencies on the foundation task, we are going to run it first and let it complete before starting other tasks. We will select our repository, then we will select a branch. We will now see the Continue button. When we click the Create button, the repository will be pulled, and the AI agent will start the coding task. We should see our task move from to do to in progress. The coding agent is now going to read the document, and you will see the output of its reasoning underneath the item on the right-hand side. The agent is indicating that it cannot find the document. This is one of the nuances of working in a dev container. Even though the documents exist in my file system, they have not been added to the repository, which for our mounted volume is the root. Because of this, the agent cannot find the files. So before completing this, I need to add the markdown documents to the repository and have the agent pull the main branch into its working branch so it can have the document we instructed it to read. I've opened Visual Studio Code in our local file system in our repository. I have copied the file system's markdown documents to the root folder of the repository. I'm going to commit and push these changes so that our agent can find the markdown files it was looking for when it pulls the main branch into its working branch. Now the main branch has the markdown files. Using the same to-do item, foundation, I'm going to add the prompt instructing the agent to pull main into the working branch, where it will now be able to find the file it was looking for. The agent is letting us know that it can now find the file that was missing from the first run. As this is running, the agent will give us a summary of what it is working on and some of the reasoning logic that it is using. After letting the agent run for a few minutes while it was iterating, correcting, and verifying any code, it runs the test suite that it created. Because all the tests passed, it is ready to commit the changes to the working branch of the repository. When the agent is finished with the commit, Note that in the lower right-hand corner of the prompt window, it goes back to its default state with a send button, disabled until instructions are given. Earlier, the button was showing a wait spinner with the text stop. When you see this, this means the agent is still busy. It is important to take note of this, as this will indicate when we are ready for our next steps. At this point, you could give the agent more instructions, but in our case, we have committed and we are ready for the next step, which will be to open a pull request. We do this by first clicking on the Open Workspace button. The workspace shows the current state of the repository branch, including agent steps taken for the task, along with the commit statistics outlining change files and replaced files. In the right-hand corner, we can see an Open Pull Request button underneath the name of our parent branch that we wish to open the pull request to. We are going to open a pull request. When we do this, the agent will generate pull request comments and thoroughly outline what was done. It is important to let this step complete before approving the pull request. Approving the pull request early may result in merging the branch before the agent has had a chance to write its detailed comments. We will know when our agent has completed when we see the orange button labeled Stop, change to the default state, Send. We can then click on the Open PR button, which will take us to the pull request on our GitHub repository. After clicking on the Open PR button, we are taken to our first pull request. We can see that the agent has created a detailed summary for this pull request. We can see the repository skeleton, the main dispatcher, the test infrastructure, as well as a description as to why the changes were made. Underneath, we can see the implementation details and the verifications. Let's take a look at the repo changes. On the left, you can see that the files were added in the bin directory, the lib directory, and tests. We can see a common shell script and a WP shell script. These represent foundation scripts that successive tasks will reference. This is why it was important to create the foundation scripts first before running the other tasks. After a code review, we are going to go ahead and approve and merge this pull request into our main branch. After merging, we are going to delete the branch as we no longer need it. Heading back to Vibe-Kanban, we can now see that our PR is marked as merged. After the PR was created, it was moved into the review state. After the PR was merged, it was marked as done. We've completed our first task. Now, we are going to move to our second task. The second task is labeled as Spell Words. After a failed attempt to create the issue for the second task, we look to our right and we will see the agent cannot find the markdown files. This is the same issue that we ran into with our foundation task. In our foundation task, we had to instruct the LLM to first pull the main branch into the working branch. You can see that such a mistake can create cascading issue for the rest of our work items as they are currently defined. Now we could either modify each task and instruct the agent to pull the latest from main, or we could use a built-in feature of Vibe-Kanban that allows us to go into the workspace settings and append a system prompt. Every time the agent starts a task, it will read the instructions from the prompt. Here, we will add a system prompt telling the agent to first pull the main branch into the working repository, so the agent will have the file that we instructed it to look for. Because our second task was already in progress, for good measure, I'm going to add the prompt to the agent's instructions for the second task. I am not sure this is necessary, however. We can see in the agent output, the agent is pulling the main branch into the working branch. It should now be able to find the document that we requested in the instructions. I've let the agent run with the second task, and it has created a PR for us. I've gone ahead and approved the PR and merged the code in. We are now ready to start running our remaining tasks in parallel. To do this, we're going to click on each item in the to-do list. We're going to open a workspace, and then we're going to click on the Create Issue button. We do not have to wait for it to complete before moving on to other to-do items and doing the same thing. As mentioned, the integration task is something that needs to be run when all other tasks have been completed. Right now, the agent is working on each task in parallel. You can see that the running tasks have been moved to the in-progress swim lane. After letting the agents run for about 10 minutes, our tasks have completed. We can see underneath each to-do item, there are no longer any wait indicators. When tasks are running, wait indicators will be shown. We can open each individual workspace for each to-do item and create a pull request now. I've gone ahead and reviewed the code on GitHub. I've approved the pull request and merged all the tasks into the main branch. Now that this is complete, we are ready to start our final task, which is the integration to-do item. For our final integration task, because it depends on the main branch containing all of the changes so far, I'm going to be extra careful, and I'm going to instruct the agent to pull from the main branch, just in case that was not clear from the markdown document. Then I will go ahead and create the issue and let the agent work on the final integration task. After letting the agent run, I have created a PR. Here, you are looking at the pull request that was generated for the final integration task. If you look at the summary, you can see that it has created a README file, which will contain the instructions for the installation and usage of the spell checker tool. This was included in part of the markdown instructions for the integration task. Because all code tasks would theoretically be complete, the integration task would have all the information it needed to prepare a structured README file.